You can see my screen, right?
Yeah, we can see.
Yeah.
Okay, so today we'll be doing Java Lab 2, right? Uh figure out that. So I guess I'm hoping everyone in this this is Python, no, Java. I'm hoping everyone have gone through everyone, not even gone through, everyone has done lab one right now. Everyone right here has done lab one, whether by themselves or the one we did in the previous tutorial. Lab two. Yep. Okay, so we have to write a code. You can see my screen, right? The question screen.
No, we can't see any screen.
Sorry?
No, we can't see any person screen.
Oh, you can see my screen.
I can just see the names of people who have joined, but your question screen, we can't see it.
I can't see your screen at all.
Oh, sorry. Yeah. Well, no.
Yeah, it just came up.
Great. Thanks. Okay. Let's just dive into it real quick. I think it's a bit much, but let's see what we can do. Write a code to compare integers using if statements, relational, and equality operators. So basically, today we'll be looking into writing logics, right? Basically business logics. In the previous tutorials, we've talked about variables, we talked about data types, we talked about basic operations in Java, like how to actually have a Java code, right? Having a Java code, your templates, your class, how to write a class, how to write a method. And we also talked about input scanner, where if you want to collect users input, you can use input scanner to get users input. So today we'll be writing business logics. I think like doing a couple of if else's and I think loops. Yeah, let's dive into it. Use 6 if statement to compare two integer input by the user. If the condition in any of these if statement is true, the statement associated with that if statement executes and displays the fact. Note, each print in prints statement resumes displaying character from where the last print or print statement stopped displaying characters. Unlike print, after displaying its argument which adds an end of line, print does not position the cursor, the output cursor at the beginning of the next line, blah, 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 blah. All this is saying is that there's a difference between print and print. Let's just get into it. I think we saw this last week, but since it's up again, let's just look at it once again. Where's my VS Code? Here it is. Okay, so I'll just create a new folder in my tutorial. Say lab 2, new folder, lab 2, create, open, new file, lab2.java. Let's do that again. Delete. I don't know if I have lab2.java. Sometimes it takes doing it again to bring up the class automatically. So first thing after class is your main method, public static void main string array of string, call it tags. Then we have our main method. So the difference between print and print. print, let's see the first one, ordinary print, say I, hey, right? So if you play that, you get I, hey together, like no line, no space, nothing, just everything comes together. But when you use print lane, right, it gives you, like, once it's finished printing that line, it takes the cursor to the next line. So you have your I, you have your A, print line, it's everything inside it owns the whole line, whether the line is full or is not full, takes up the whole line, push the cursor to the next line once it's done. Same thing happens with this one, push the cursor to the next line once it's done. You can see that even this one, the cursor was still in front of the IA because we were using just print. But this one, this gives us a new line. This also gives us a linear, moving the cursor to the next available space. So that's all they are trying to say here. Now, to the task of the day, creates, just like, I actually like the way what's his name? Trying to get the name of this person. Yeah, Jean-Claude. How he does is, at least how his questions, like the way he writes these stuff, he, at least for the beginning, he takes you through what you're actually supposed to do. So create a file, create a lab2 underscore 1 Java file, and create a main method. So let's do that. Create a new file inside that same your lab2 folder, lab2 underscore 1 dot Java, and create a main method, public. I don't recommend this for people just starting, but to save time, if your extension is working fine, if you type main, you should bring out the method. But for
Main.
it's for the start, right? Try and type it so that you don't forget it. The more you type, the more it sticks in your head, because you might think the main will work. It doesn't always work. When you get to the exam hall, you might type it and it won't work. So it's better to type it yourself and make sure you know how to do it. Whether it works in the exam hall or it doesn't work, you know you're covered. Main string, array of string, call it args, and that. So we're done with question 1. If they are marking this, let's say this is 4 marks, you've gotten 1 mark. Let's go and work for our second mark. Create code to allow user to enter 2 integers using the scanner and assign each of the value into 2 variables called number 1 and number 2. So basically, you have to do 3 things here. 3 things mainly, but it's a bit much. You need, number 1, you need a variable to hold your scanner. You need another variable to hold number 1. You need another variable to hold number 2. So let's go from understanding of scanner last week. You need to get scanner from it's a Java library. So you need to import it. You don't necessarily need to know this if your what's it called? If your Java is installed properly, as you are typing this, just don't finish typing. You can see as you are typing it, it's coming. So just click on, if it's not scanner you want, if it's schema, you pick it. But for us, it's scanner we want. So we just click on it and it imports this thing for us automatically. You might not always know where it is, where it's stored. So you need to rely on the system. This drop down, this is one thing that VS Code will do for you. You need to rely on VS Code to give you a direction of where it's coming from. Then it's imported for you automatically. You give it a name. My new scanner equals new scanner. We saw this last week. Scanner. Let me type it myself. I need system.in. I explained what all these ones are done last week. This is just you declaring a variable. You remember variable definition, your data type, variable definition, your data type, your variable name equals value. So this is scanner is a data type. It's actually a class for this variable definition is a data type. This is our variable name and this is our value because it's a class. So we are calling the class, right? And it collects an input. The input is system.in, meaning it should be listening for data for input. You should be listening for input from the user. So that is, we've done this. Then we're asked to also do and create a code to allow user to enter two integers using the scanner and assign each of the value into two variables called number 1 and number 2. So we need two integers, right? Integer number 1 equals, we don't know yet. Let's just say this. We don't know what we want to put, but basically we actually know. But let's take it one bit at a time. We need two integers. Integer number 2, right? That's the declaration. It says we should save what's inside it, what the user is going to input. So we can just say, since we know how to use scanner, so my new scanner dot next int, right? Then we do the same thing for this one. My new scanner dot next int. That's it. So that answers, read the question again. Create code to allow user to enter two integers using scanner and assign each of the values into two variables, number 1, number 2. So if you run this, it's asking you to enter something, say 12, enter something else, say 13, and that's it. That's all. Question 2 is saying create code to allow user to enter two integers, 1, 2, and assign each of the value into variable called number 1, number 2. So we're done with this. Question 2, we are done. That means we have 2 marks. Let's continue. Write this conditional statement to perform the following comparison. Comparison operation. Equals, not equals, greater than, less than, greater than, equals to, and less than, equals to, and display a message when this is true. So all what this is telling us is that we should, let's pick it one by one. We should check number 1 against number 2 and see if they are the same number, right? So how do you write an if statement? If number 1 equals number 2, then say S out what? Number 1 is equals to number 2. Just number 1 is, or if you anyhow you want to write in English, first number is equals to second number. To give you an idea of what to write here, if you have this, right, if you have these, if there is an option, if they give you this output, then you can look at what was actually used in the output. If this was not given, then you have the sole responsibility of figuring out anything you want to put here appropriately. But right now, all they are saying, what they put here is number 1 is equals to number 2, which is, okay, let's just change it. That was actually what I was writing before. Number 1 is equals to number 2. So that's it. Then we are done with the first one. We need the second one. Now, if else, when you're dealing with, I'm guessing you guys have gone through, what's that? I've gone through the class notes because the class note would have explained some things. Now, if it's called a conditional statement, right? They are conditional statements. They are used for checking conditions, like what happened if something happened, something else should happen. If there is rain, then we are not going to school. If the weather is good, we are going to school. Just the way you said it with your mouth. If weather, I don't think I know how to write weather. Weather equals good, depending on what, if weather is good, then print we are going to school. I'm hoping we get this. It's just if your condition inside, note the brackets. This is where the brackets comes in now. You can see the brackets are different. If with a normal bracket, your condition. So this is how it goes. If your condition. Now, what is your condition? Your condition can only be, can account, it could be either true or false, but it could be a calculation, right? Your condition should either be true or false. I hope you're getting this. Your condition should either be true or false, but your condition could be an expression that amounts to true or false. Here, what I am actually expected to write here is if true, do something. If false, do something else. But we don't always know if it's true or if it's false. So we can put a condition saying if you analyze this condition, the condition is going to give me true or false. The condition is if weather is good. Then we'll go to our phone and we'll check the weather. Okay, what's the weather? The weather is good. That gives you either true or false. Weather is either good or bad. So at the end of the day, it is either true or false. So you don't necessarily need to put true here or false here. You can put a condition if 22 equals 2. Automatically, this is going to give you false. Now you see all these things you see here, they are called conditional operators. Give me a minute. It's not conditional operators. It has a name. Operators, Java. Just a minute. No, arithmetic operators. We saw those ones last week. Assignment operators. What we're looking for. Logical operators. Not logical. Comparison operators. Yeah, this is what I'm looking for. Comparison operators. They are used for comparing. The English is just eluding me. Don't mind me. They are used for comparing, for comparison. You want to compare something. And what is the whole idea of comparing something? It's to give you, if I say, okay, I am taller than Yunus. That is either true or false at any given time. I am either taller than Yunus or I am shorter than Yunus. So if I say I am taller than Yunus, that's a statement. It is either true or false. I think it's false though. I'm not sure. But that's the idea. Your statement is going to give you either true or false. You can't put something else here. Like I said earlier, let me backtrack again. What this condition is expecting is either true or false, right? Or false. Both of them works. But if you don't know yet, let's say there is a survey that, okay, we want to know Yunus or Tony, who is taller, then they need to get both of us to school. Like both of us needs to go to school and do measurements before they can know. So we don't know yet. So you can't just say it's true. Tony is taller, or it's false. Tony is not taller. You need to get us together first. You need to make the comparison before you decide who is taller. So to make the comparison, you can say Yunus equals Tony, or Yunus greater than Tony. Now that is where all these things comes into play. They are all comparison operator. This is equals meaning Tony's height is equals to Yunus' height. You get, this is not equals, which means like this two like this is called not equals. Tony's height is not equals to Yunus' height. This is greater than, which means Tony's height is greater than Yunus' height. Same thing with this less than. Tony's height is less than Yunus' height, and greater than equals to, less than equals to. Greater than equals to means, well, it could be Tony's height could be greater than or could be the same. So if Yunus' height is 2 and mine is 1, then this will amount to false, because we'll be having something like 1 greater than or equals to 2. Yunus is 2, that's Tony greater than or equals to 2. That will be false. So let's do what we are asked to do. So if condition, then your code block. If condition, then code block. You remember from last week, I said when you want to write a code block, this is what you use. This kind of bracket, this is a code block. From here to here is a code block. From here to here is a code block. From here to here is another code block. So when you are dealing with code blocks, you are dealing with this kind of bracket. When you are dealing with parameters, arguments, you are dealing with this kind of bracket. These are like parameters passed into this if. It's not really a function, but let's just take it that way, that is, they're like arguments used alongside if to give us something. So here, according to the statement, it says we should use any of these. So we have number 1 equals number 2. So what happens is it checks this 12 against 13. So it's 12 equals to 13. If 12 is equals to 13, then it says number 1 is equals to number 2. If it's not, then it doesn't do anything because we didn't tell you to do anything. Now that is the next thing with if statement. There's what called if else. If else, yeah. Let's pick else first. Then we could have else, another code block. So here we could easily say else, right? S out. Number 1 is not equals to number 2. I hope we're getting this. So if number 1 is equals to number 2, we definitely get number 1 is equals to number 2. Else, which means they are not the same, then it's going to print out this. Let's play this and yeah. So I'll put 12 again and 13 again. Then it says number 1 is not equals to number 2. Let's try that again. 12 and 12. Number 1 is equals to number 2. Now you have a working if else statement. Now, one thing with this thing is, like I said, you are here. So forget the idea that programming is a different, something that is for elite or something you can't understand. It is English. So when you are solving things like this, you don't necessarily need to understand it like as you are going. There might be some places along the line that we might make mistakes with the answers. You analyze at least you have a test case. Our own test case is 12 and 13. You analyze it that, okay, this is not supposed to be equals, it's supposed to be not equals. Then you fix it up. Let's say what we had here was number 1 is not equals to number 2, right? Let's say this is what we're doing, and we run this code. We put 12, we put 13. Number 1 is equals to number 2. This is wrong. This statement is wrong, right? So this statement is wrong. So it's not like your code is bad. Your code is not bad. Your code is working fine. It's just made a business mistake. It's not even a programming mistake. It's a business mistake. Like I said earlier, this is called business logic, conditional statement, and iteration, looping. We'll get to that in a bit. They are called business logic. So what just happened to me here is not a programming mistake. You are not at fault, although if you submit it in the exam board, you will still miss. They will still give you 0. But it's actually not a programming mistake. It's a business logic that we got wrong. So what is the business logic we are getting wrong? There are 2 ways to fix it. You can change this to not equals, or you can say, I have made a mistake with the printout, so just change it up. My code did not break. It's just my business logic was wrong. 12. Number 1 is equals to number 2. I hope we get that. Let's get back to the business of the day. So it says, write this conditional statement, perform the following comparison, blah, 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 blah. Okay, there are many ways of writing this, but I think what they want is for it to only show what happened, right? Actually, this is very correct. Let's just go with the literal understanding of this question. It says you should write 6 different conditional statements. So let's forget else. We've done equals, just copy and paste, don't mind me. 1, 2, 3, 4, 5, 6. That's not equals, greater than number 2. Number 1 is greater than number 2. Then the next should be less than is less than, and this should be greater than equals to, greater than equals to, greater than or equals to, and this should be less than equals to, less than or equals to number 2. Right? This is what. So if we use their test case, which is 3 and 5, 3, 5. So we get number 1 is not equals to number 2. Number 1 is not equals to number 2. Fine. Number 1 is less than 2. Jesus Christ. Okay, let's do that again. 3, 5. Number 1 is not equals to number 2. That's fine. Number 1 is smaller than number 2. Number 1 is less than number 2. That's fine. Number 1 is smaller equals than number 2. That's nice. Number 1 is less than equals to number 2. Yeah. So we're getting somewhere. I guess the next question is going to treat some things, but at least you get what is going on here. So basically just using the operators to check against the stuff. And if you want to write it the way they wrote it, I think there are some fancy stuff there. You can just print out. So let's just print this out. Enter the first number. Enter the first number, right? S out for the second number. Once they finish entering so it prints this one, then they enter the number, then print another thing again. Enter the second number. Then they enter the second number here. Then it starts these calculations. Enter the first number 3. Enter the second number 5. Then we get that. So you see, you don't necessarily have to write, like, your code doesn't have to be perfect at the first go. You keep improving it. Don't just leave it until you have a perfect code before you run. Write one line, run it. As long as, don't just write this line and run it too. You need a framework. Like, you need, not a framework, you need a frame. Still a frame. You need the class and the main method. Once you have that and you have something in between it, you can keep running every time to know which point you're at, which point, what you need to add, what you are doing. If you've made a mistake, you can easily fix it. It's not after you've written 1 million lines of code that you now run it, you now discover number one is doing something that is not supposed to be doing. You work progressively. So that's that. We're done with task 1, I guess. Enter the first number 3, enter the second number 5, and we got our answers correctly. Let's go to number 2. Write a code to analyze exam results using while loop and nested control statements. Now, this is the second aspect of business logics. The first one is conditional logic, conditional operator, which is what we've seen. The second one is loops, iterations, anything you want to call it. The whole idea of loop is you want to keep doing something for a number of time. Anytime someone approaches the door, keep opening the door, right? That's, you give it a condition. As long as there is people in front of the door will stay open. You get? Then once there is nobody again, it closes. Or you can leave it open forever. But mind you, that can spoil the door. The same way it can spoil the door, it can spoil your code. If you do something like this, then go down with this. Loops. You say there are a bunch of loops. I will just go into it in the meantime. I'm just giving you the general idea of loops. So let's say you have int x equals 0, x less than or equals to 0, x plus plus s out x. Let's see if I say this. I just want to give you an example of something that can not just spoil your code, but spoil your system. So you just get hot in very fast. 12, 13. You can see in like 1 second, so freak. It's counting from 1, no. It started from 1, but we can't see it. We've reached 9,200 and I can't pronounce it. So if you leave this running, before you know it, if you touch the top of my system, the thing is turning like it's smoking now. So this can easily get out of hand if you don't control it. You need to understand what you are doing here. I didn't print anything. I was just doing something else. Probably I was doing 2 plus 2. I just did 2 plus 2. I won't know something has gone off that is doing something forever. And that can easily, you will just discover that 1, your system is getting slower. You are typing 2, you will go and take tea in the kitchen and come back before the two will show. Then, boom, to start smoking. So be careful of how you use loop. We'll see good examples in a minute. I'm just trying to give you a caution. You should be conscious when you're using iterators. They are very, very, very they can put you in trouble. Yeah, so basically is you can see what it's doing. It's doing something forever. What I did here was for x equals 1. If x is greater than 0, originally 1 is greater than 0, and we are we are still incrementing x. So on the first iteration, it did okay, it's 1 greater than 0, it printed 1, right? Get
Plus,
back. Sorry.
plus, so if you skip this one greater than 0, then you continue with this x plus plus. Is this still going to run like this?
For traditional for loops goes like this. I'm not treating this yet. I'm just giving you. I just wanted to show you what happened here. I would treat for loop separately. Just give me a minute. I will still come back to for loop. I am just giving you an idea of what happened here. The whole idea of loops. So what happened here was for I initialize x to 1. Then I'm checking is 1 greater than 0, which is true. I will run this. That means it will print 1. Comes to this x plus plus, change x to x plus plus means increment x. So x changes to 2. Comes back to this condition is 2 greater than 0. So it keeps going like that. Is 9 blah 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 greater than 0? It says true. Print it. Come back. Increment it to 9 2 blah blah 1. Is that greater than 0? So it keeps doing it forever, because your condition will always be true. As long as you are incrementing, your x can never be less than 0. So this will always be amounting to true. And as long as this is amounting to true, we'll continue doing our village thing. So but let's see live examples. Okay, this is a simple program to demo how to use a while loop. So now, before I go into that, loops, there are different types of loops. Like, but basically, for almost every programming languages, you're going to see the traditional for loop. Call it traditional because they are fancy for loops in all these fancy languages. Now, if you go to Python, there are some very fine for loops inside, but there is a traditional for loop that in every language. That is, you will always see it that way. This that I wrote here, this is a traditional for loop. There is while loop, and I think, okay, I don't think Java has do while loop. Let me just check in a minute. Loop, while loop. Yeah, they have do while loop. So there is for loop, there is while loop, there is do while loop. Traditionally, those 3 loop iterators, you'll find them in almost every programming language. So let's go into it. Sorry, I keep going and coming back. I'm just trying to make sure we are getting the idea. Okay, the control is simple. You enter 1 for pass and 2 for failure. Any other entry to exit the program. So there are 3 things that our program is going to collect: 1, 2, or any other thing. 1 means pass, 2 means fail, 3 means we're done, 4 means we're done, 5 means we are done, A means we are done, full stop means we are done, space means we are done. I don't know if 20 means we are done. That's what this thing is telling you. 1 for pass, 2 for fail. Any other entry exits the program. You accumulate the number of passes and failures in 2 variables as you go along imputing your scores. Then when the data entry is finished, you display the result. Now, what this is saying we should do is we want to create a program where we want to probably have sum of all the marks of people that took an exam. So let's say 2 people are sitting down. So somebody will just be calling it for me. Anthony scored. Anthony passed. I'll type 1. And Jonas passed. I will type 2. Malcolm passed. I will type 1. I keep typing 1 for passes. Right. Then when we get someone that failed, I type 2. Like I just type 2. Like you just say, okay, Anthony passed. I type 1. Enter. Jonas passed. I type 2. I type 1. Enter. Somebody failed. I type 2 now. Enter. That means that person failed. And that person failed. I type 2. And that person passed. I type 1. Right. And when we are done, probably there are just 5 people in this class. I type anything and I exit the program. So that is what we want to build. So let's go into it. Create a Java file called lab2_2. So lab2_2.java. Right? So we're done with that. We're not done. Create a main function. So main. Don't forget, don't do what I'm doing. I'm just trying to save time. Write it normally. Declare and create a scanner object. This will appear in the exam hall. If this is the same, let's say this is the same paper we're having in the exam hall. Once you see questions that are similar, just go and do copy and paste. Do copy well. Now this is what we actually brought. It does the input automatically. So copy and paste just to save time. Declare and create a scanner object for your input. Bam. Declare 2 integer variables to hold values for passes and fails. So 2 integer variables. So integer variables, both of them are integer. So I could do something like this: passes, comma, failures. Because both of them are integer, I could easily do something like this. If they are different data type, you have to separate them. You get? The same thing I type here, I could have also done int passes, int failures, right? This 2 lines is the same thing as this 1 line, but we always try to minimize the numbers of lines we're typing as much as possible. Don't just minimize. Note the word behind it: as much as possible. If it's not possible, don't cram everything together. But this is possible, so I can easily turn 2 lines into 1 line. So I do it. Okay, let's continue. Declare a Boolean variable to control the while loop and set it appropriately. So we want to do a while loop. Now, what is the structure of a while loop? While loop goes like this. While your condition, then do something. Your code block. It looks more like if statement, but they are different in the sense that if it's just checking a condition, it checks the condition once and that's all. But while we keep checking the condition. Now let's go back to lab2_1. If statement just check this condition once, is number 1 equals to number 2? If it's equals, print it, and that's all. If this had been while, it keeps going back. Is number 1 still equals to number 2? Print it. Goes back again. Is number 1 still equals to number 2? Print it. Still goes back again. Is number 1 equals to number 2? Print it. So that's the difference between the if statement and the while statement. The while keeps going back until the condition inside the while is false. Then it leaves the block. So now what they are saying is that we should specify this condition so that we can always come back and edit. We can always refer to that condition and do something about it. So we say we can say something like, it's going to be a bit, like I said, anything condition here is going to be either true or false. That makes it Boolean. So Boolean condition, we can just say condition. This is just a variable name. I'm just giving you to understand what I'm doing here. Condition that controls the while loop equals, let's say true, because we actually want the while loop to start. Right. So what we want to do is we want to say while condition that controls the while loop do something. Please, I don't know if I can get just one or two person that can just tell me I'm still on the right track. Like, yeah, I know it can be business study can be a bit complicated, but I will get in it. The class is a bit silent.
Bro,
Yes,
you're killing it,
okay.
man.
Let's go
You're
ahead.
killing it. You're killing it.
Yes, yes, that's
All
very
right.
good.
Thank you. So the condition, the while loop giving us a condition. So at this point, what we have here is while true, because our condition that controls the while loop is actually true. So what we have here is actually while true, then do something. So what are we supposed to do inside the while loop? Although we've not actually gotten there, but number 4 says declare a Boolean variable to control the while loop and set it appropriately. So this is our condition that controls the while loop, and we'll set it appropriately to true, right? So now in the while loop, first display enter result, right? 1 for pass, 2 for fail. Yeah, so let's just S out. I'll just do copy and paste the code so I can use it directly. S out that, right? Then get user input. So once I do this, I can now come and say, okay, user input. I'm expecting an integer, right? Integer, can call it user input. I'm bad with names, don't mind me. Anything that comes to mind. User input equals, what's the name of our scanner? My new scanner, right? My new scanner dot, we're expecting an integer, so next int, bam. So 5a, first display this thing, then get the user input. Display, get user input. Their statement, as long as you understand what it's saying. Now, the understanding is what we did last week. Understanding, okay, when you see the statement, this is what it means. Collect something, this is how you collect. Print something, this is how you print. Right? Declare a variable, this is how you declare. As long as you know this, every other thing is English. First display something, that means they are telling you to print. Then get user input, that means they are asking you to use scanner. I hope, because the biggest part of the biggest challenge in programming is actually understanding the requirement. Once you understand the requirement, you're good to go. So increase pass if 1 was entered, or failure if 2 was entered. So we are expected to keep increasing something. Now, we can't increase this because, okay, let's just go ahead. Like I said, your code cannot be perfect on the first. It can be perfect, but it's not expected to be perfect on the first run. You keep improving it. So this is saying that we should increase pass if 1 was entered, or failure if 2 was entered. So there is an if here. There is a condition. I hope we're getting this. There is a condition. It's English, but even in the English, they've been giving you int. Right? If 1, if 2. If the person entered 1, or if the person entered 2. In our own code, it means if user input is 1, or if user input is 2. Now, one thing that was not treated here, I thought it would be treated, but it wasn't treated, is if else. I talked about it briefly, but I thought it was to be treated very well. No, but it wasn't. I think it was in the class notes, so you can go back to the class notes and look at it, but we'll just talk about it in one more, like briefly. So if weather equals good, print we are going to school, right? Then you can also have else if weather equals bad, then you say print we are not going to school, right? Else if, right? You're saying if the weather is good, we are going to school. Else, you supply another condition to the else. Else, if weather is now bad, we are not going to school. You can now keep doing else if until you are satisfied, right? You can still have else if weather, I hope my weather is correct. If weather equals worse, right? And you say, okay, hell no, we are not going to school, right? Just hell no, no school today. Keep doing it, and at the end of the day, okay, you don't have anything else to check. You can say else, like if any of these things. Now we'll explain something. Just let me finish here. I will explain something very soon. Else print. Well, we don't know yet. We don't know yet. Now, there is a difference between why I wrote A and why I have A. Now, you remember when we ran this, there is possibility for multiple answers. 12. Let me do that again. Let's use the 3, 5 for formula. 3, 5. There are possibilities for multiple answers, which means these things were analyzed separately. This one was 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 analyzed separately, and we're getting the answers separately. But you see, this one, else if, only one of it will be analyzed. Now, let's use the same example. You can see the result of this one. We got 3 things. Now, let's change this to else if. Else if. Else if. Else if. Else if. And else, at the end of the day, we don't even know what the person entered. We can just say you entered your village thing, right? We couldn't analyze what the person entered. So now check out the difference between the answers. 3, 5. No, that is not what I want. What just happened? Did I save it? Just a minute. 3, 5. Yeah, I think memory. Now, note the difference between these answers. Here, there was possibility for multiple answers. But you see, for else if, there is only possibility for one answer, because it will analyze the first statement. Is it true? If it's true, it will print it out, and that's all. If it's not true, it will go to the second statement, analyze it. Is it true? If it's true, it will sort out the code block, and that's all. If it's not true, goes to the next one. Because we are using else if, right? So if you are using else if, there is only possibility for one answer, the point where your condition is true. Then if none of your condition is true, let's say you've entered your village thing here. If none of the, I don't think it will, you can do that, but if for some instance you've entered your village thing truly, then if you have a catch block, or it's not really a catch block because there is also something called catch block. So let me not use catch block. If you have this else, which means if none of those conditions at the top are actually true, then we can say, Bros, you entered your village team. I hope you will get that. This is a joining statement, our conjunction, I think in English. This is for conjunction. You are joining them, you are concatenating statements together. You are joining statements together. But you see the ones without else. Sorry, all these ones without s, there are several they are different statements. This is a different statement. This is a different statement. This is a different statement. You will notice that when I added those else if, when my code was formatted, this is my code originally, but once it formats it brings everything together, because you see all these things like this. It's just one line because of this else if. Everything like this is a single line because of this else. But these are separate lines. I hope we understand that. There is if, there is else if. If is a single statement. Else if, if is a separate statement. Like if you have multiple ifs, they are separate statements. But once you introduce else if, then until the last else, everything inside that statement is a single statement. Continue. So that will be helpful in what we want to do here now. So increase passes if 1 was entered, or failure if 2 was entered. So what we want to do is, if user input equals 1, right? 1, then we say passes plus plus. We just want to increase passes. But it's telling us passes cannot be resolved to a variable. This my passes is not correct. And it's saying the local variable may not have been initialized. Now, this was what I wanted to correct earlier, but I want us to actually see the error to know that you don't actually need to. If I had to figure out this one earlier, like if you check the code, you would have seen that it did something here, but it wasn't actually in the question. So you're like, okay, where did I get this from? What's going on? You don't need to figure things out. Where you need them, the code itself will tell you need it. So what it's saying here is passes here is not, we don't understand. So what is it? You are adding one to something we don't know. We have it, it's declared, yes. Declaration here means just leave us. You call everybody remembers undergraduate in Nigeria, though. I don't know of any other country. Hello, keep seats for me. At least in my school, we do it very well. Keep seats for me. You are still in your own village. They are keeping seats for you in the class. So that's just the same thing declaration does here. Keep seats for me. We don't even know what is inside or what. And they kept it for you. We don't know, and we are saying you are still calling out another person. So that is, the analogy got wrong somewhere. But basically, to fix that, you initialize it. So you initialize it to 0. So the number of passes we have is 0. The number of failures we have is 0. So if the person entered 1, we increase passes. Plus is the same thing as passes plus passes equals to passes plus 1. This is the same thing as this. You can see this is longer than this. And like I said earlier, if it's possible to shorten it. So this is possible. Passes plus plus means passes plus 1. Else, if user input equals to, we want to increase failure plus plus, right? Else, now remember what I explained here. We're expecting 3 things, either 1, 2, or something we don't know, like something else. So if taken care of one, we've taken care of two. Now let's take care of something else. We don't know what that something else is, so we can't really say condition. You could start saying, okay, else if user input equals 3, else if user input equals 4, else if user input equals 5, and account for every key on your keyboard. You can do that in your village way, but we won't be doing that here. We'll just say else. Once it's not 1 and it's not 2, plus you enter your village to exit. Actually, it's telling us to exit. So any other entry to exit the program. So how do we exit the program? This is the add bit of this code. How do you exit this program? They all, from the explanation of why is while true, keep doing this. So at the point where this condition that controls the while loop changes to false, this thing will not run again. So all we need to do is to find a way of changing this thing, this true here, to false. Once we change it to false, this while loop changes to false, and automatically this thing won't run. So all we need to do is to say condition that controls the while loop equals false. Bam. So if you enter 1, we will increase passes. If you enter 2, we increase failure. If you enter any other thing, we'll close the program. If 1, passes. If 2, failure. Anything else, close the program. Condition that controls the while loop changes to false. So once you finish this, it goes back up and say, while, condition that controls the while loop is now false. We're done. Go to the next line, which is anything on that displays. So let's run the code and see what we get, at least for now, to see that things are working fine. 1, 2. So okay, we've not even started. 1, 2, 1, 2, 1, 2, 12. So 12 actually closes the program. Same thing goes for, the program has even closed. So you can't enter anything other than 1 or 2. Any other thing closes your program. So you've done that. If any other, increase passes if 1 was entered, or failure if 2 was entered. If other value entered, display message that data entry is done and terminate the while loop. Okay, we are supposed to display a message first. So S out. Just copy and paste. Data entry is done. Data entry is done. And terminate the while loop. Terminate the while loop. You get. So display the result using printf method for both variables when data entry is done. So let me see the result. The result is supposed to be like this: data entry finished, program editing. Let's actually do this. Program ending, sorry. Data entry finished. Program ending, right? Then we want to write passes 3, fails 2. So using printf, we saw printf last week. So we know from what we're doing, we know by at some point, if the person has entered 1, we would have been increasing passes or increasing failure. So let's now print the collation of everything using printf. S out. I'll just change this to F and say passes. So you remember how to use printf. Passes is something that we don't know yet. How do we do something that we don't know yet? We use placeholders. So what's the placeholder for integer? Placeholder for integer is D. Please go and study printf. Study printf a bit. I think you can get printf here. Printf. Java printf. W3 schools. I don't need Python, I need Java. This is print line. I need printf. Hey, someone, if this is okay, we might actually need just type remove the W3 schools and it should be. Yeah, you should study this. You can study, you can see these things have every data type has their own arguments to use. So just, but commonly, the common ones are string uses %s, integer uses %d, float and booleans uses, sorry, float and double, no booleans, float and double uses %f. I think from the top of my head, those are the ones I remember. So passes, we know that integer is d. The place where that will be d, and here's a question again. Fails to, so fails, we say another %d. Basically, this is what we want to write. Passes equals the passes that is up here. Base passes. But if we put it here, it is village string that will be printed out, and it's not village string that we want. So, and this failure, right? Failure is fails is failure. But if you do this, you get a village string 1, 2, 1. Not even started the program. 4. Then you get passes, fails. This is not what we want. We want this passes to be a number, this failures to be a number. This is passes, this is failure. So then you replace it with %d, and supply the values for each of the %d. The first one, which is passes, is passes. The second one, which is fail, is failures. Failures, right? So if we do that again, 1, 1, 1, 2, 2, 1, 5. Data entry finished, program ending. Passes is 4, fail is 2. So let's count the number of passes we actually 1, 2, 3, 4. So that's correct. And fail is 1, 2. So that's 2. So that's how we go about that. So all we were doing here, you can see passes was actually 0, failure was 0, but with our conditions, we've been incrementing it behind the scene, even though you don't know. And that's the idea. There are all those applications you use on your phone. You just type something, but some things are going on in the background. But at the end of the day, they might give you the result or they might not give you, I don't know. But a lot of things are always going on in the background. In the background, we're actually using the input of the person to do some calculations. It could be like we were multiplying, or we were doing average, or we were doing anything, or we were doing something in the background where, okay, if the person entered 1, we're increasing passes. If the person entered 2, we're increasing failures. Then when the person is done, the person can just enter anything on their keyboard and boom, they're done. So that's that. So you can see we have that and we have the same thing. So let's go to number 3. Write a code to analyze this man and his English. Write a code to analyze exam results using while loop and nested control statements. Now, before I go, he supplied some pseudocode here. These are called pseudocode. Pseudocode means your code written in English. It's not even like that. An explanation of a step-by-step guide of what you want to write. So, okay, I wrote this because I actually know what I wanted to write. But if I don't know, I could look at the pseudocode. Okay, the first thing is saying, okay, declare variables. That's us declaring all these variables, right? Then he said, create user input, which is the scanner okay, which is this one. These are the variables. This is the scanner. Declare and assign a value to Boolean. Okay, they are actually using continuing input. So if you want to follow these, pseudocode, for example, the first thing is declare variables. So that's this one. Int passes. I don't know if this thing works now. It's still not working. Int passes. So bring this one up, right? That's this line, declare variables. I'm just showing you how to work with. Okay, how to work with pseudocode. So you have declare variables, create input scanner, or you can actually just copy everything then sort out. If God wants to help you and you have pseudocode, then put your pseudocode in your code and just sort out the values into it one by one, as long as you know what you want to put. Okay, so declare variables. Those variables are these ones. All right. Create user input with scanner. That's this. Declare and assign a variable, a value to Boolean continue input. We are calling our Boolean continue input. I don't need this again. All right, so then it's going to be, instead of all this, my long one, it's going to continue input. Then while continue input, to write a while loop. So it's going to be, for this one, it's going to be while continue input, right? Bam. So I think all these ones goes inside the while. If you look at, they're actually indentations. So they've actually done the big work for you here. So they are actually, let me take this off for a minute. All these things were indented originally. So it's actually like this. So while continue input, then this. So I'll bring back the while continue input, right? Then user types a number. So user types a number. Where's my user types a number? This is it. User types a number. User types a number. If number entered is 1, increase passes. So if number entered is 1, that is this one, increase passes, right? If number, you can, let me bring this back to the, let me bring them to the mid, to inside this thing. So okay. So you have your this. Don't worry, this is the last time I will be doing this. I just want to give you an idea of how to sort out, how to use pseudocode, because this is a very good thing to have. If you have this, then have more than half of your problem is solved. So user types a number. This is where we'll collect the number. If entered number is 1, so that's this one. Increase passes. So bring in increase passes to the increase passes. So take this off. Then else if, you can see it, else if number is 2. There is an indentation here. If you note there are indentations. So just follow the indentations. The indentations are very important. So the next thing is if number is 2. So where's our if number is 2? This is it. If number is 2. If number is 2, increase failures. This is increase failures. Increase increase failures, right? Then else, you can see when you read the pseudocode and the code together again, you now see that both of them are actually the same thing. It's just some bit of some differences. It's English at the end of the day. So else, this is our else. Else, display a message. This is our message. And set Boolean continue impute to terminate the loop. So this is how we are terminating. Okay, we are using continue instead. Continue impute equals false. That is how we are terminating, and we're going to close the else and display number of passes and fails in printf. Display number of passes and fails in printf. Bam. You have your code. So the same thing you have in the pseudocode is the same thing we actually did. It's just like I just wasn't following. I forgot it was the word. I've actually followed this. I wasn't following the pseudocode. So if you follow the pseudocode, declare variables, you did it. Declare a scanner, you did it. Declare a new variable, call it, which is a Boolean, call it continue impute, you did that. I keep on following, do a while loop. They even gave you the name for the while loop. Me that was looking for a name. They've given you a name. So that's what pseudocode does for you. Gives you a breakdown of what you want to do. Then you can transform it into code using any programming language you want to use. This I can easily turn into Python. This I can easily turn into Java. This I can easily turn into C. This I can easily turn into JavaScript because it's just a pseudocode, it's English. So depending on the language you want to use, you just slot in the syntax. That's it. So if you run this again, you should still be good. Let's actually use the value they used. So 1, 2, 1, 1, 2, 1, 1. So 1, 2, 1, 1, 2, 3, 2, 3. And they have passed 3 fails 2. Yeah, so that's it. So I think the only thing that was left out of the pseudocode but was in the answer is this one. Enter this particular line, and you can easily slot that one in. That's at the top of your while loop. So at the top of your while loop, print this out, that, and you are good to go. 1, 1, okay. 1, 1, 1, 2, 3. So you have that. Okay, let's move on. Number 3. Write a code to analyze exam results using while loop and nested control statements. Use a code for question 2. The purpose of this exercise is to add extra code so you can use the percent of passes given several entries to display a message if blah, 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 blah. So this is what needs to be added to the while loop. So basically we want to now start working on the final result. We want to do some analysis. Okay, what's the percentage of people that passed in this class? What's the percentage of people that failed in this class? Mathematics, business logics. So what are we expected to do? The first thing, let's say you are not given the pseudocode. I'll come back to the pseudocode in a minute. Let's say you're not given the pseudocode. You first need to understand this. What are you expected to do? The purpose of this exercise is to forget all this extra code. What are we supposed to do? You can use the percent of passes given in the English is a bit bad. Don't mind him. You can use the percentage of passes given in several entries to display a message if the number of passes is over 50% of the number of entries. So you have basically what we have here is passes and failures, right? So if we have 3 passes, failures 1, number of entry automatically is 4. So the person entered something 4 times. How do you calculate an average? You need the total, right? So let's say 1, 1, 2, 1, 2, 4. So we have 3 passes, 2 failure, which means the total number of entries is actually 5. 3 plus 2, and if you can't say it's 1, 2, 3, 4, 5, it's going to be 5. Aside the last one that exits the system, but the total number of entries is actually 5. So you need that, and basically they are trying to see if the total number of passes is greater than, is greater than 50%. If the number of passes is over 50%, right? If the number of passes is over 50%. So you want to do that first. So one thing we want to add here is at the end of the day, we want to say, total number of entry, integer, right? Int total number of entries equals passes plus failures. And that was what I did. Passes 3 plus 2, which gave me 5. So passes plus failure. So basically, the total number of entries is everything that was entered, right? Then you want to check the average. The average of, you want to check the average of all the entries. So int, that might be a decimal. So you want to take care of decimal places too. So double average mark equals total number of entry divided by 2. It is just pass and fail we have, so we just want to, that's why we have 2 divided by 2. That gives us the average mark, right? And then saying if passes is, we should display this. So if passes is greater than what we get here, well, we can actually use, I'm just trying to use names we are familiar with, but double half entry. So this could be half entry, and our number of entries, that's, we've calculated those ones earlier, total number of entries. So divided by 2, that gives us half entry. So that gives us half entry is the same thing as average. So we can now go ahead and say if passes is greater than half entries. You can actually, as you're going, let's not even make things complicated. As you're going, you might want to check things out. S out half entries. What is total number of entries? That's how true, because when things start getting complicated, writing them out, writing your code at once might be hard, because you actually don't know. You did it fine, but you don't actually know if the calculation of total number of entries was correct, if half entry was correct. So you might want to check them out as you're writing them. Half entries, and okay, S out. Let me even see what passes also is, so we know we are still on track. So I put 1, I put 2, I put 1, I put 2, I put 1, I put 1, I put 3. Then forget, okay, I need print line here. I need let me just terminate this. There is a bit of overlap here, so I will just use new line to terminate that. So 1, 1, 2, 1, 2, 1, sorry, 1, 1, 2, 3. So I have this one. So the first thing is total number of entries 8. Yeah, 5 plus 3 is 8, but that's fine. Half entry is 4. That's what is expected. 8 divided by 2 is 4, so we are still good. And passes is 5. So okay, we just want to check if 5 is greater than 4, right? So if passes is greater than half entries, then print out bonus to the instructor. This out. Done. So let's run that again. 1, 2, 1, 1, 2, 1, 3. So bonus 3 instructor, half of the students passed. That's because, okay, our half entry is actually 3 and our passes is 4. You can see if you calculate it manually, 4 plus 2 is 6. The average of 6 is 3, right? No, sorry, 4 plus 2 is 6. The average of 6 is 3, and your passes is 4. So 4 is actually greater than 3. So which means half of the class actually passed. So that's fine. Let's do one tricky one. 1, 2, 1, 2. Now what happens here? Half of the, I made a mistake. Round that again. 1, 2, 1, 2, 4. What happened? Passes is 2, fail is 2. Total number of entries 4. Average is 2. Passes is 2. 2 is not greater than 2. Had it been this is greater than or equals to, it could have been fine, but 2 is not greater than 2, so we can't use this. Sorry. Okay, we can use, we can't say 2 is not greater than 2, so we can't execute this particular line of code. And also, if fail is, let's say 2, 1, 2, then we won't also have it because fail is 1, average is 1. 1 is also not greater than 1. So that's that. And once you are done, since you are not expected to print out all these ones, you can just take them out. They are just for debugging, right? All this system out that I did earlier, they are just for debugging. So take them out and we're good. And if you check your pseudocode, if passes is greater than half entry, print out this, and that gives us what we need. Okay, number 4, write a code to calculate the compound interest with for statements. So we've seen while loop. Now let's look into for loops. I told you we had for loops earlier, so let's look into it now. Brief: a person invests £5,500 in a $500 in a savings account, yielding 5% interest, assuming that all the interest is left on deposit and no money is taken out of the account. Calculate and print the amount of money in the account at the end of each year for 5 years. Compound interest from your primary school. Don't worry if you have forgotten. Me too, I've forgotten. But lucky enough, they gave us the formula. So this is what we are asked to do. We are asked to calculate the annual interest. We have been given P, a principal, which is 5, is the original amount invested, which is $500. 1 plus R rate, which is 5%, that's 5 over 100, 0.05, and N number of years, which is 5 years, that's 5. So the first thing you want to do is, if you want to take it one bit at a time, you can declare this variable. Okay, I think there is, this. So if you feel like reading these things, you can read them. I don't think I want to do that, so I'll just go ahead and, okay, one bit to note here. Now, there are math operators. I think if you've been going to class, you would have seen him using math.random, and math.random, math.py. There are some how do I put it? There are some operators, functions that comes along with the math class. It's called a class, and these are methods. There are some methods that came with, there are some classes that came with Java, the same way this scanner came with Java, because we are not the one that installed this scanner, we are not the one that wrote it, we don't know where it came from, we just knew, we called it and it answered us. The same way we can call the math class to give us some math, all those stuffs, all those fancy stuffs you do in maths, calculus, logarithm, pi, power, square root, you can call the math class to give you those methods. So one of the methods you get from the math class is power, which sorts out this problem for us, right? Gives solves this problem of, okay, how do we do this power? So the math.power helps us with that issue. I think we need to, I'll just go to the task. I think we're running out of time. So create lab2_4, the fourth one. When did you do the third one? Okay, this is supposed to be the third one. That's fine. Lab2_4.java. Thank you. My main method. Thank you. I've done that. Create two double variables to hold values of the principal and the interest rate, making sure that the variable holding the rate is a constant. Okay, that's another thing that was just introduced without telling us. Double principal, we just call it P, and double interest rates, we call it R, right? But they talked of something here. They said we should make sure it's a constant. How do you declare a constant? You introduce the final keyword. Final makes this a constant, which means you can't come back in the future and say R equals, okay, we can actually have, you can have R equals 1. This is fine. Well, R equals 2. Then this brings an error. Now, this is what they call a constant. Is a variable? It's a variable, right? But it's a constant. It can be changed. It's a variable you can initialize, but you can't change. That is why they call it a constant. And once it gets its value, that's the final. You can't give it another value. The same thing we did for R. Let's do it for P and C. Maybe we're missing P, right? That's fine. P equals 2. That works fine because P is not a constant. P is a variable. But R is a constant. The final keyword makes it a constant. I hope you understand that. So when you see constant, the next thing that comes to your mind is final. So they are saying, making sure the variable holding rate is a constant. So the variable holding rate is R and is a constant. Declare an integer variable to hold the number of years, assign proper value to it. So we hold years, integer, they said it should be an integer. We call it Y. Now let's just give this thing proper names. Principal rate, years. We don't know the values yet, although they've given us at the top. Okay, this is it. So I'll just slot them in a minute. Blah blah blah. So they said we should do something, but let's slot in the value. The value for principal is 500.0. Principal is 500.0. Rate is 0.05. 0.05. Years is 5. Years is 5. We're done with that. Okay, assign proper values to it. So that's where you assign values. We're actually following the manual, so we're still good. Display using the printf method the values of the 3 variables, use blah blah blah. Okay, use end line tab to format the output as shown below. Add another line for the header. This one's English here. J and amount against using tabs. They are just telling us to do something like this. So we have principal, we have rate, we have number of years. Then they are saying we should have an header called J and amount. So let's just do that. So the first line is this one. Print, S out. We are told to use printf, so that's fine. We can whip something up. Principal 500. That's this one, right? So how do we slot it in? Is a double. Remember what I said from here? When you are dealing with float or double, you use %f. When you're dealing with printf, so %f. We'll come to formatting it in a minute. Let's just go on. %f. Then okay. We need rate. We need, this is not normal space. Let's just continue. Let's continue. Let's make it progressive. Rates equals, rate is also a double, so %f, right? And number of years, that's an integer, so that will be %d. And I think we're done with that. And we need this on the new line, year and amount. So we could just say new line. We know how to do new line from previous classes. New line, year, amount, right? Let's see what we get. Okay, we have some values we need to slot in. If you run this, it's going to throw an error. Yep, because we have some places that we've not sorted. So let's sort them. The first one is principal. So that will be principal, right? The second one is rate. That will be rate. The third one is year. So that will be years. Right. So play. So we get principal with one very long number that we don't know where it's coming from. Rate doing the same village thing, and number of years doing the same thing. And there are spaces here that we've not seen, now we account for. So let's start with the easier ones. So how do we account for these spaces? If you could start putting space, but we won't do that. We just use something called tab \, the same way we are putting a new line. So
الله أكبر الله أكبر أشهد أن لا إله إلا الله وأن محمدا رسول الله حي على الصلاة على الفلاح قد قامت الصلاة قد قامت الصلاة.
Who is in this one now?
Okay. So principal, we put %t, that gives us a tab. We want to do the same thing for year, t, principal and rates. Yep. Play it again. That's my system slow to do. So okay. We have principal, I think we have number of years too. So how do we account for these zeros? That is where formatting comes into play. That was why I was trying to get this document out for you. You see all these things I mentioned here, all these %s, %d, %f, you can format them. Well, try and read that on your own. I will just give you this. To format, we want 2 decimal places here, as we've seen from the result. 2 decimal places, 2 decimal places. So you just put 0.2. Now we'll 0.2f. Same thing for the rate, 0.2f. This means 2 decimal places. If you put 3, it means 3 decimal places. If you put 5, it means 5 decimal places. For f, like anything that we are passing into this f, format it to 2 decimal places. Anything we are passing into this second f, format it, which is rate, format it into 2 decimal places. That's it. So let's run that again. We're getting there. Okay, let's also format this here, and let's just add a tab. And yeah, I think it looks alike. Principal 5,500. This one. Yeah, looks like. Okay, let's move on. In the for loop, follow the pseudocode below. Note that we start with year 1 and not 0, as this is for the following year. Now, this is how to write a for loop. For, although is small letter, for year, your initialization of your variable. We are using a variable in our stuff. For year, okay, we'll call this thing years, right? So we'll go for year, we initialize the condition and the incrementation. Remember what we did here? I don't know if I still have it or I deleted it. Yeah, look at it. You initialize your condition and your incrementation. Initialization, condition, increment. So what does that mean in code? It means for our year, we know it's going to be an integer. We want to pick this year one by one and show the values. So we want to show 5 values: year 1, year 2, year 3, year 4, year 5. So we want to loop 5 times. We want to do this calculation. We want to do this calculation 5 times. So how do we do that? You can do it one by one 5 times, but that's not what we want. We want it 5. We want just we want to use a loop. So you can say int a, any variable you feel like using. Int a equals 0, right? A less than or equals to yes, because where our condition is working against yes, right? And a plus plus. Initialization, condition, incrementing. You get? Now I think the way they did their own is a bit different, which is fine. So they're using 1. Okay, let me actually understand what I did here. I'm trying to count from 1 to 5, right? So I say the first thing that actually happens here is 0. So that's not what I want to do, right? What I want is to count from 1 to 5. Count from 1 to the number of years, right? So int a equals 0. I want it, which means the first thing that actually comes up here is 0. That's not what I want. I want a to be 1, the initial a to be 1, because I want to count from 5 to 1. If a is less than yes, print. So let's just do 0 first and do, so we understand what I'm saying. S out, a. Oh yeah, see this 0 here. Yeah, you can see starting from 0, 0, 1, 2, 3, 4, 5. That's not what we want to do. We want it to start from 1. So all you need to do is to change this to 1. And 1, 2, 3, 4, 5. So this is what we want. We want our stuff to start from 1 and count all the way. So we want to do it. We want to do something 5 times. The way we've printed 5 times, we want to do something 5 times, but it's not printing. Compute the new amount following giving the formula above, display the new amount. So using this formula, using this formula here, so we'll say double a equals, what is p? P is principal. So principal into brackets, just bear with me. We know this is multiplication, so 1 plus rate, then what's it called? Okay, we have a before. Okay, just to make things easier here, if you can see they use year, right? It's just like, how do I put it? It's just any variable. I just don't want to use year, not to confuse you. What they are just doing here is they got a new variable and they are just saying, okay, inside a bunch of years, give me one year, but not to confuse you. That's why I used a. Well, I still don't want to confuse you, so I'll use b instead, because I need a for something else. B. What are we even calculating? What are we calculating? Compound interest. Okay, let's just leave it the way it is. We'll call this interest. We want to calculate the interest, right? So interest equals principal times 1 plus rate. Then this this thing here that we don't understand yet. Now, this is how to write power. Power. This is how to write power. Let me just show you. Maths.power. Now you can see power collects two things. POW collects two things. The first one is the value that is collecting two things. The first one is, you can, from mathematics, I don't know if I'm not supposed to be explaining mathematics. This n is only applied to this 1 plus r. So this is the first value of power. This is the second value of power. Like this n is the second value of power. This thing is the first value of power. So if you want to use power, then you want to do something like maths dot power, right? Then this is the first value. 1 plus r is the first value. The second value is your number of years. Now, even though this is two things, it's still one value because it is by comma that we know that we count values. So anything before the comma is one value. Anything after is also one value. Like if we have another comma here, then we have another value. But the fact that this is 2 does not mean that I have 3 things here. Like if you look at it from a layman's view now, we have 1, 2, 3 things here. But no, we have 1, we have 2. This is a statement. This is another statement or an expression. I hope you understand that. So our principal multiplied by the power of 1 plus r. Our principal multiplied by the power of 1 plus r. Then, but because the way math.power is written, everything goes into the bracket math.power. The first value is the main value. The second value is the power. So the first value is your 1 plus r. The second value is your power, which in our own case is rate, which is year. Sorry, in our own case is years. So that's why we have that. Then you can say print. Let's just see what we get. S out interest. Yeah, we got something, but it's not looking like what we were supposed to. We got something fine, right? We got, at least we are still getting something. Well, that is not. So our years, instead of using years here, we are calculating for each year, right? But years here is 5. So which means it's for the first year, it's calculating 5, 5, 5. That's not what we want to do. We want to do 1 year, 2 year, 3 year, 4 year, 5 year. And from our initial stuff we did here, we know that A is 1, 2, 3, 4, 5. So instead of using years, which is just stagnant at 5, we can use A, which increases on every iteration. So we change this to A and we run that again. So we get 5.25551. So at this point, it's used 1. At this point, it used 2. At this point, it used 3. At this point, it used 4. At this point, it used 5. Right, but it's still not looking like what we want. So let's just format it. So instead of using this one here, we use F and we use let's just copy. Okay, we can copy. That's not good. Okay, yes, that will be we want, if you put years here, you will just get percent D. You can see, so this is percent D, this is percent. This is your year 1 by 1. This is your values that you calculated. So I'll just say percent D and tab, then percent what. Interest is double, so year interest. So year is integer, interest is double, so that will be F, right? So the first thing D, That's year. Our year is A. Don't forget we are using A, not years. Years is 5, but A is 1, 2, 3, 4, 5. So if you use years, let's just see what we get. If you use years, what you get is 5, 5, 5, 5, 5. That's not what you want. And your percent F, which is interest. So let's see. Assignment. Okay, I need a new line. New line. So 5, 5, 5 is not what we want. What we want is 1, 2, 3, 4, 5, which is A. You get for every iteration. So let's do that. 1, 2, 3, 4, 5. Then for each of those years, you get a value. And I think we introduce a space here that we were not supposed to introduce. Let's bring it back. Yep. And I think, yeah, values in 2 decimal places. So let's format it 0.2. There you go. You have your answer the same way. It's just once you get your calculation right, everything is just formatting. Just keep tuning it, testing it until you get your formatting right. So that's that. Let's go to question 5. I think that's the last one. Write a code to calculate the compound interest with 4 statements. Same 4 statements. Use the code. Blah 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 blah. Use the code for question 4. Enhance your program so that the user can enter the principal, the rate, and the number of years before computing the result. Okay, that's fine. So instead of us putting static value here, they want the user to enter it. So let's just ask the user, right? Let's just ask the user. So we say, let's bring in scanner. User input, so let's just call it, let's give it a good name. My scanner equals new scanner system.in. Then let's just S out something. How much do you want to borrow? Right, now say that will be principal, right? So principal equals my scanner dot, we're expecting the double, right? So we'll collect next double instead of, we've been saying next int before, but now we named a double, so we use next double. So our principal is next double. We do the same thing for our rate. So this is we should collect rate, the principal, the rate, and the number of years. So rate, please enter the desired rate. I think that's correct. Enter your, imagine if you can tell the bank the rate you want to use. Please enter your desired rate, right? So say rate equals my scanner, give me another double. Then I need the number of years. Please enter your desired number of years. That will be years, and that will be next int, because years is an integer, so we use next int instead. So we get everything. We get our principal. I think this thing is it's getting a bit complicated. It's getting a bit. So you get your principal, you get your rate, you get your number of years, collecting it from people, collecting it from the user, right? So how much do you want to borrow? Let's just format things to make sense a bit. Let's not use print line. Let's just print, so it will be on the same line. Yeah, you know what? I'll just put this thing here, new line. Now we put new line here. We'll put new line here just to make sure things are new lines. It's just formatting. I don't want that stuff to break down. So how much do you want to borrow? I want to borrow $500. Please enter your desired year. Oh, okay, that makes sense. I don't need this. You see, it's just play around with it until you get your desired output. How much do you want to borrow? 500. Please enter your desired rate. 0.0. Okay, I need this year also. I need this year also. Let's run that again. How much do you want to borrow? 500. What's your desired rate? 0.05. How many years? 5 years. Then we use that for our calculation. Principal 500, rate 0.05. So let's run those with a different value. 6,000 for 0.02, right? And for 20 years. So that's how much you pay if you borrowed. If you actually save, it's not borrowed. Compound interest. If you saved 6,000 at the first year, you get 6,120, and at the 20th year, you get 8,915 points, blah 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 number. So that's it. The fourth question is just to, instead of coding values, you want to collect, because at the end of the day, you're building the program for people. You're not building it for yourself. So if you supplied 500 and myself, I want to borrow 6,000, that doesn't make sense that you will calculating 500 for me. I want to be able to enter what the number of years I'll borrow it for and the amount I actually want to borrow. That is where the input now comes into play. You want to calculate somebody's age. You want to tell everybody in class that, okay, by next year, you're going to be, I'm 12 right now. By next year, I'm supposed to be 13, and I'm the one writing the code. I had coded 12. So when Yunus runs it, it's going to tell Yunus by next year it's going to be 13, but Yunus is not going to be 13 next year. It's going to be, I don't know, something greater than that. So you want people to be able to supply their own value. That's where the user input comes into play, and that's what the fifth question is just emphasizing for us. Done a lot. That's it for lab 2. Do we have any question? Hello. I hope I've not been talking to myself for the past 2 hours.
Oh, I got
No.
too much.
Now with you.
Okay. Do we have any question? Okay. Let me see. Does it make sense?
Yes, very well.
Yes, so
Yes,
makes
it
sense.
does. Thank you.
Thank you, man. Thank you.
Yeah. So basically, if you try and do it on your own, I don't know if you're coding along. If you're not, try doing it on your own. At any point where you're having issues, go back to the videos. I'll try and upload the videos tonight and send the links. Go back to the video at the point where you have issues and see if you can get it sorted. I don't know if that's okay. Okay. If there are no questions, that's everybody. Thank you everyone for coming around.
Thank you very much, Tony.
It's been a great.
Thank you.
Yeah, we'll see you in class tomorrow to continue the battle. All right,
Yes,
now.
thank you so much. I appreciate it. Thank you.
Yeah.
Anthony for president.
Sir?
Don't worry, contest for president. I'll do it.
Nah, I no get president before.
Guy, all right, this thing don't scatter. Make I go rest my head. My head dey hot. Very much. Yes.
Please, can I have a question?